to the third lesson on solving polynomial and rational inequalities. We use the sign table to solve inequalities with multiple factors. The product or quotient of several factors is positive or negative depending on the sign of each factor. The sign table of an expression indicates the signs of all its factors and the overall sign of the expression. Let's consider the expression x plus 1 times x plus 2. The sign table has a row for each factor. X plus 1 and x plus 2. This is the number line that goes from negative infinity to infinity. We indicate the zeros of the two factors and we determine the sign of each factor around its zero. X plus 1 is 0 at negative 1 and x plus 2 is 0 at negative 2. Looking at x plus 1 only, x plus 1 is positive when x is greater than negative 1, that is to the right, and it's negative when it is less than negative 1. Looking at x plus 2 only, x plus 2 is positive to the right of negative 2, and it is negative to the left of negative 2. The product of the two, which is our expression, will be negative times a negative equals positive to the left of negative 2. Negative times a 0 equals 0 at negative 2. Negative times a positive equals negative between negative 2 and negative 1. 0 times a positive equals 0 at negative 1, and positive times a positive equals a positive to the right of negative 1. The sign table shows that the product of the two factors, which is our expression x plus 1 times x plus 2, is positive in the interval from negative infinity to negative 2 union negative 1 to infinity, is equal to 0 when x is negative 2 and negative 1, and it is negative in the interval between negative 2 and negative 1. Now for the expression x plus 1 divided by x plus 2, we create a similar sign table that has a row for each factor, x plus 1, x plus 2, the number line, the zeros. This will be negative 2 for x plus 2, and it will be negative 1 for x plus 1, and then the signs around their zeros. X plus 1 will be positive to the right and negative to the left of its 0. X plus 2 will be positive to the right and negative to the left of its 0. Divide them to create our expression. Our expression is x plus 1 over x plus 2, and we get negative divided by a negative equals to a positive quantity, and negative divided by a 0 is undefined, and I mark this with an X. Negative divided by a positive is a negative quantity. 0 divided by a positive is a 0 quantity, and positive divided by positive is a positive quantity. So we have to be very careful when we have quotients of factors, because division by 0 is undefined, but 0 divided by a non-zero quantity is equal to 0. The sign table shows that x plus 1 over x plus 2 is positive in the interval negative infinity to negative 2 union negative 1 to infinity, It is equal to 0 only when x is equal to -1. It is less than 0 in the interval -2 to -1 open, and it is undefined when x is -2. Now note the difference, that if we are asked to solve the inequality x plus 1 times x plus 2 greater than or equal to 0, then that is in the interval -∞ to -2 union 1 to infinity, but -2 is closed because x could equal to -2 and -1 is closed, whereas when we are asked to solve the inequality x plus 1 over x plus 2 greater than or equal to 0, that is also in the interval -∞ to -2 union 1 to infinity, but at -2 we cannot have a closed interval because x cannot equal to -2. There is a domain restriction that doesn't allow the denominator to be 0, but x could equal to -1.